we have solved problems based on development of surfaces of cylinders, cones and pyramids. Today we will be solving problems based on development of surface of prisms. Problem number 7. A pentagonal prism with edge of base 40 mm and height 90 mm is kept on HP on its base. Since it is given that the prism is kept on HP on its base, it means the prism is a vertical prism with height 90 mm and side of base 40 mm, and edge of the base is parallel to VP. So it is given that the prism is resting in such a way that one of the edges of its base is parallel to VP. In the second statement is given, it is cut by a plane inclined at 30 degree to HP and bisecting the axis of the prism. So in the second step, we have to cut the prism by a section plane which is inclined at 30 degree to HP and passing through the center of the axis of the prism since it is bisecting the axis of the prism. So let's begin with the solution. In the first step, we will draw a pentagon with a given side. So we have drawn a pentagon of side 40 mm. After drawing the pentagon, name all the corners from A to E. Since there are 5 corners, we will get 5 points A, B, C, D and E. In the next step, we will draw the XY line. Now you can see that the side DE is parallel to XY line. In the question it was given that one of the sides of the base of the prism is parallel to XY line. So while drawing the pentagon, we have drawn the pentagon in such a way that one of its sides, that is D to E, is parallel to XY line. Now we will project the points A, B, C, D and E on the XY line one by one. So we have projected all the points on the XY line. Now we will mark the height of the prism which is given as 90 mm in the question. So the height of the prism is equal to 90 mm. After marking the height, we will name the point A on the top also. So this vertical line A to A represents the vertical edge of the prism. Students, in cones and cylinders we draw generators, whereas in case of pyramids we draw slant edges, but in case of prisms we don't have slant edges, we have vertical edges which is equal to the height of the prism. So the height of the prism is 90 mm, so the vertical edge A and A will also be equal to the 90 mm. Since it is a pentagonal prism, we will have total 5 vertical edges passing through points A, B, C, D and E. So we will draw all the vertical edges one by one. So I have drawn all the vertical edges, total 5 edges: vertical edge AA, vertical edge BB, vertical edge CC, vertical edge D to D and vertical edge E and E. Students, you can see here that two vertical edges, that is D and E, are hidden because when we see the front view from the top view, from this side only 3 points are visible: point A, point B and point C. So the vertical edges passing through these points will also be visible. Hence A, B and C are dark, whereas these points will not be visible from the top view. So the edges passing through E and D will be hidden. So we have drawn hidden lines. Now we will develop the lateral surface of this pentagonal prism. For that, first project the height of the prism in the side view. After projecting the height of the cylinder of the prism in the side view, we have to mark the first point. Since here we have total 5 points, we have to mark all the points here one by one. We will mark the first point, that is point number A. You can mark this point A anywhere on this line. It is not necessary that you have to mark here only. You can mark here also, you can mark here also. After marking point A, draw vertical line passing through point A till the top line and again mark point A. So this is my first vertical edge A and A. Now the next vertical edge will be BB. To mark the vertical edge BB, take the distance on the rounder from A to B. Place your rounder at point A and cut an arc in front of it. So second vertical edge B and B. Similarly, you have to mark the remaining vertical edges C, D, E and again A. So we will mark the other vertical edges one by one. Vertical edge C. Now distance A to B will be equal to B to C. Similarly, B to C will be equal to C to D. So finally we have completed all the vertical edges from A to E, and the last again will be A. Now since it is a pentagonal prism, we will have the lateral surface as rectangles. You can see that is a pentagonal prism, so we will have total 5 rectangles in the lateral surface. First, second, third, fourth and fifth. In case of pyramids, students, we develop triangles in the lateral surface, but in case of prisms there are no triangles. We have to develop rectangles in the lateral surface, since the lateral surfaces are plane rectangular surfaces. So total we have developed 5 rectangular surfaces, 1, 2, 3, 4 and 5. Till now we have developed the lateral surface of a pentagonal prism without considering that it is cut by a section plane. But in the question it is given that the prism is cut by a section plane. Now the section plane is inclined at 30 degree and bisecting the axis of the prism. So this vertical edge is coinciding with the axis of the prism. So we have to draw the section plane from a point at the center of this HBB. We will mark the point. Since the total distance is 90 mm, the line bisecting the axis will be at a distance of 45 mm from the base. So you have to take a distance of 45 mm from the base and draw a light horizontal line. So this point will be the point of bisection, and the given section plane will pass through this point. So we will draw the section plane at 30 degree and passing through this point, that is the center. So the section plane is inclined at 30 degree. This angle is 30 degree and it is passing through the center point since it is given in the question. Now we will mark the points of intersection. Again, points of intersection will be those points where this section plane cuts the vertical edges. So this section plane cuts vertical edges AA, E to E, B to B, D to D and C to C. Since it is cutting the 5 vertical edges, we will get 5 points of intersection. We will mark the points of intersection one by one. So first point lying on A, second point lying on E, third point lying on HB, fourth point lying on HD and fifth point lying on HC. So there are 5 points of intersection where the section plane cuts the vertical edges of the prism, and the section plane was inclined at 30 degree. Now we have to mark these points of intersection in the lateral surface. So it is very simple. You have to just project the points directly in the lateral surface. So we will project the points one by one. So the first point 1 is projected. Now point 1 lies on edge A. So wherever this line cuts the edge A, that will be my point number 1. Similarly, we will mark point number 1 here also. So edge AA and again edge AA is cut by this line at these 2 points, point first and point 2. So both these points are marked as point number 1 since 1 lies on A. Now the next point is 2. 2 is lying on edge E. We will draw first horizontal projection line in the lateral surface. Now wherever this line cuts the vertical edge EE, that will be marked as point number 2 since 2 is lying on E. Similarly, we have to mark point 3 on vertical edge B and B. So we will project the point 3 in the lateral surface. Now wherever this line cuts vertical edge BB, that will be point number 3. So this is my point number 3 as point 3 is lying on vertical edge B. Now the next point is 4. We will project the point 4 in the lateral surface. Now point 4 is lying on D. So wherever this line cuts the vertical edge D, that will be marked as point number 4. So this is my point number 4. And the last point is 5. Now point 5 is lying on vertical edge C. So first we will project the point 5 in the lateral surface. Now wherever this line cuts the vertical edge C, that will be my point of intersection. So vertical edge C is cut by this line at this point. So this will be my point number 5. So finally we have marked all the points of intersection. Now for joining these points of intersection, you have to keep in mind that these points should be joined with the help of a straight lines and not curve, since the lateral surface of the prism is a plane surface. So these points should be joined with the help of straight lines. So we will join the points one by one: 1 to 3, 3 to 5, 5 to 4, 4 to 2, and 1 to 2. So finally we have drawn straight lines passing through the points of intersection. All these lines should be dark. Now after drawing the lines of intersection, this upper part should be kept as light, because when the section plane cuts this prism, the upper part is removed, or we can say only the lower part is retained. So only the lower half, that is this portion, should be dark, whereas the upper part should be light, that is these vertical edges should be light. Also these projection lines should be light. Now we will darken the remaining edges one by one. So vertical edge 1 to A, 3 to B, 5 to C, 4 to D, 2 to E, and 1 to A, and finally the base. So only this part should be dark, because this part is not retained, the upper part is not retained, so it should be kept as light, whereas the lower part, which is the retained portion, should be dark. Also in the front view, the portion lying below, that is 1 to A to C, and C to 5, that is this portion on the lower side, should be dark. The edge 3 to B should also be dark, whereas all the edges on the upper side as well as these lines should be light. And finally in the top view, this pentagonal prism should be dark, or we can say that this pentagon should be dark. So finally we have completed the development of the pentagonal prism. Thank you.